Let's take a look at this example. This time we are going to have ones in cell 0, 1, 2, and 3. Anytime you are going to have 1 in every single cell of K-map, the answer is going to be always equal 1. So if you want to implement it, this is nothing else, just your VCC. Okay, you are going to connect your system or your circuit to the power. Okay, so this is going to be always equal voltage source. Let's take a look at this example. This time we are going to talk a little bit about the don't care component. So how we are going to place everything into the K-map. I have ones in cell 0 and cell 3. And I have don't care component. DC stands for don't care. Don't care I'm going to have in cell number 2. Don't care we can use or don't use. We use it when it's going to work for us. We don't use it when it's useless for us. But in this case, don't care can be very useful. Why? Because if I would not have don't care, I would have these two ones placed diagonally. We are not going to be able to simplify this function. So if I'm going to use don't care, I'm going to have two groups. This group is placed in 2 rows and 1 column. Please check what we have on the side of these 2 rows. We have complements. Anytime we have complements B0 and B, we simply ignore them and copy down everything, whatever is at the top of the column. So I have A0. So I have A0. Next group is placed in 2 columns and 1 row. On the side of this row, I have B. And at the top of these 2 columns, I have complements. I ignore complements. That's why this is the reduced Boolean expression for my problem. And if I want to implement it, this is nothing else, just inverter connected to input A. And this is OR with input B. This is my output. These are the solutions to my problem.